very similar to 4.1a. It talks with vertexes, max and min value. Okay, so the first thing we need to figure out is if we have a graph, okay, and we have a quadratic function, so anything with x squared in it, okay, it should look like a u. Okay, and so down here, there's going to be a point where it's the bottom of the graph. Okay, this is going to be called the minima. Okay, and this was anything where a x squared plus bx plus c, and where a is positive, it's going to go up. Okay, where a is negative, it's going to look like this. Okay, so something of that sort, where there's a top of the graph. Okay, so that's going to have a maximum. Okay, so that's going to happen where ax squared plus bx plus c, where a is negative. Okay, so anytime a is negative, you're going to have a maximum function. Okay, anytime a is positive, it's going to be a minimum. Okay, bottom of the hill, it's a minimum. Top of the hill, it's maximum. Okay, and again, anytime you want to find the vertex, okay, which is what we're finding here, it's negative b divided by 2a. That's your x value. Okay, and then you just plug it back in, whatever you get, and that's your y value. Okay, so this is the key. Again, okay, so you need to remember negative b divided by 2a, and that's the entire portion of this 4.2b. That's all they're trying to get at. Okay, so let's look through the questions. The questions are mostly story problems. Okay, so you got to be able to draw it out. That's the key here. Okay, so the back of Tom's property is a creek. Tom would like to enclose a rectangular area using the creek as one side. Okay, so rectangular area, it's like a rectangle, but the creek is one side of this thing. Okay, so it only has 3 sides of fencing. He has a total fence. He has 920 feet. Okay, so that's all we have to work with. He needs the maximum possible area. Okay, so remember, area of a rectangle is length times width. Okay, so we need to know what the width is, and we need to know what the length is. Okay, we know we have 920. We know these 2 sides are the same. Okay, so let's just say those 2 sides are x. Okay, well, let's say I use 1 foot of fence here, 1 foot of fence here, so I've used 2 total feet of fence. How much would I have left? Well, if I had 1 here, 1 here, I would have 918 left. And that's because I'm just minusing these 2 off. So this is going to be the total minus these 2 off. Okay, so that's the most important part, being able to set it up. Now to find the area, again, it's length times width. Okay, and I want to maximize that. Okay, so I'm going to say I want to max, and I want to max this, so it's length times the width. Okay, so I'd FOIL this through, and so I'd get 920x minus 2x squared. Okay, and I want to maximize this function. That's all they're asking for. So my a value is -2. My b value is 920. I don't need my c because my vertex is where the maximum is. Okay, notice it's negative. So I know my graph looks something similar to this. Okay, so there's going to be a maximum somewhere. Now where it's at, I don't know. Okay, so I'm going to find the vertex of it. Okay, so negative b divided by 2a. So negative 920 divided by 2 times -2. That'd be negative 920 over -4, which is equal to 230. So I know that is my x value of my vertex. Okay, but that's not what they ask. They ask for the area, the total area at this point. Well, in order to find the total area, all I got to do is plug it in. Okay, so it'd be 920 minus 2 times 230. times 230. So that'd be 920 minus 460 times 230. So 460 times 230. And so my total area, or my maximum area at this vertex is 105,800 feet squared. And that'd be your answer. This would be the maximum area. Okay. All right, so that's how you do most of these. Okay, you got to be able to set it up or draw a picture, and then you write the equation out, you FOIL it, and then you got to find the vertex. That's pretty much the whole thing. Okay. All right. So the next one, determine whether the following function has a maximum, a minimum, or neither. If it is either a maximum or minimum, find what the value is and where it occurs. Reduce all fractions to lowest terms. Well, your function they give you is f of x is equal to 2x plus 10. Well, there isn't a quadratic. It's not squared. So this is going to be a line with a y-intercept of 10. Say there's 10. And a slope of 2. So I went up 2 over 1. And there's my line. Notice it goes up forever. It'll go down forever. So there is no maximum. There is no minimum. And so this is neither. Okay. So maximum minimum will only occur using quadratics for the most part. Sometimes cubics does, but linear does not. Okay. All right, determine whether the following function has a max or min. Okay, find the value is and where it occurs. Okay, so the value is the y value, and where it occurs is the x value. Okay, so the function they give you is f of x is equal to 5x squared plus 50x plus 122. And again, anytime they say max or min, you should look for the vertex. That's the key. Okay, which is negative b divided by 2a. A is 5, b is 50, c is 122. So negative b divided by 2 times a, negative 50 divided by 10. My x value is negative 5. Okay, and so all I got to do is find my y value at that point. Okay, so 5 times negative 5 squared plus 50 times negative 5 plus 122. When you work that out, that'd be 25, 125 minus 250 plus 122. And when you work this out, you end up getting negative 3. Okay, so this is the value, and this is where it occurs. Okay, so your vertex is negative 5, negative 3. Now, is that a max or a min? All depends on this. Again, remember when we talked earlier, if it's positive, okay, negative 5, negative 3, it's a graph that goes up since it's positive. Okay, so notice it's on the bottom of a hill, so it has to be your minimum. Okay. All right. The last one, the revenue function. Okay, so the revenue function they give you, x times p of x. Okay, so it's an x times whatever p of x they give you, and the p of x they give you is equal to 200 minus 0.4 x. But again, they're asking for the revenue, which is this. Okay, so it says find the maximum revenue. They want to maximize this, but we need p of x. Well, we haven't. So we want to maximize r of x, which is equal to x times 200 minus 0.4x. We would FOIL this in. So I'd have 200x minus 0.4x squared. Notice this is negative. Your A is negative, so that means it's a graph that goes down. Okay, I don't know where the graph is, but it goes down. So I do know it's a maximum. Whatever I find for vertex, it's the maximum. Okay, so again, negative b divided by 2a. Negative b, a, is going to be negative 0.4. B is 200. C, nothing. Okay, so negative b, negative 200, divided by 2 times a. Negatives cross off, so it's 200 divided by 0.8. 200 divided by 0.8 is 250. That's my x. So that's part of my vertex. That's the x value. Now, that is not what they're asking for. They're asking for the revenue. The y value is the revenue. Well, how do I find the y value? I just plug it in. Okay, so I plug it into this equation right here. Let's see. 200 minus 0.4. I'm going to plug it in this one. Maybe it's a little easier. Okay. Now, it doesn't really matter. So 250 times 200 minus negative 0.4 times 250. Okay. So 250 times negative, well, 0.4 times 250 is 100. 200 minus 100 is 100. And 250 times 100, add 2 zeros to this, is 25,000. And so the revenue would be $25,000. Okay, and that would be the maximum revenue you would get. Okay, so again, when they ask for anything type to deal with maximum or minimum, find the vertex. So you got to find the x value using negative b divided by 2a, and then you just plug it in. Okay, so remember, negative b divided by 2a. Let me know if you have any questions. That would be 4.2b. Thanks.